Okay, so here are 5 practice questions. Okay, on your own, I want you to identify the type of reaction that these are on paper, and then we're gonna go over it together. Okay, so just by looking at it, you write down, oh, is this decomposition? Is it double replacement? Is it single replacement? Is it combustion? Is it synthesis? Decide what type of reaction these are. Done? I don't want you to predict anything. I want you to just tell me the type of reaction. We're done? Just tell me the type of reaction. Everyone determine the type of reaction? Okay. What did you put for number 1? Double replacement. Beautiful. Number 3. It's number 3. I'm mixing it up. Single replacement. Number 2. Combustion and synthesis.
You have to put the 2.
Yes. If it is both. There's only, this is the only time where you can have both. Combustion with synthesis. Combustion because I have oxygen as a reactant, and synthesis because it's 2 elements. Number 4. No synthesis, just combustion. Synthesis only produces 1 product. This one does not produce 1 product, produces 2. Number 5. What kind? Perfect. Okay, so for double replacement for the first one, let's do it together. How would I do that one? Who's replacing? No, it's double replacement. CO3 and? Cl, what do they do? Excellent, nice. They switch. So, who's going to be with K? Right, so K, write the charge. Cl, write the charge. What's the formula? Hello? Yeah, anyone? Right, so I just gave Cl to K. I had to cross the charges. So what's my formula? KCl. Plus, CO3, he's with who now? Right, Li. So Li is what charge? Plus 1. And CO3 is? And what's the formula? Li2CO3. Beautiful. Okay, did everyone understand how I got these products? If you did not understand how I got these products, I need you to tell me.
Wait, the 2 came from the charge.
Say it again?
Li2 from the charge.
Yes, the charge of carbonate is 2 minus, so when you cross it, it gets 2. Anyone else have a question on how I got these?
How would you know the difference between single and double replacement?
Good question. So single replacement is a compound and an element. Double is 2 compounds. So see how this one has just a plain element? The single replacement ones have only a plain element and a compound, while double replacement is 2 compounds.
But
Good.
you have to like balance it still.
Everything, all the time. There's no option.
Can you just go over how to do the solubility?
Yes, I can. Let me see your paper. The solubility paper.
The number 3, the first compound. Okay, the first element, that's a compound.
The first element
Yeah, like the C.
for what number?
Number 2.
Number 3. This is a whole compound. This thing. CaNO3 that's one compound. Calcium nitrate.
What makes it a compound?
What makes something a compound?
It's more than
When you have more than one element in the formula. What is this? Compound, because there's more than one element.
But how do
Compound, more than one element.
you, yeah. But
Compound, more than one element. Compound, more than one element. 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 Compound, more than one element. Element. Compound, more than one element. Element. Compound.
how do you know that one is double? Because one being
There's 2 compounds as my reactants.
So it's compounds before and after?
Say it one more time.
There's compounds before.
Yes, so guys, I wrote all of this down on the board during the study guide. All of it. I told you how many products, I told you how many reactants, I told you what kind they were going to be. I went over all of it. So for double replacement, it's 2 reactants, 2 products, both of them are compounds. All of it's compounds. So, again, I knew that this was double replacement because I have 2 compounds reacting together. I know that this is synthesis because I have 2 elements. I also know it's combustion because I have oxygen as a reactant. I know that this is single replacement because I have a compound and an element reacting together.
single replacement compound.
I know this is combustion again because why? O2 as a reactant. And I know this is decomposition because I have 1 singular reactant. All of this is in the study guide that I told you about.
Decomposition
Every single thing.
is one reaction, and then for
Say it one more time.
decomposition
Mm-hmm.
is one reaction.
Correct.
And it yields 2 products.
Correct. Depending on what kind of decomposition. Yes. Okay, so I want to find the states of matter for this. KCl, Li2CO3. Okay? Okay, how do I know how to find the states of matter? So this is the compound I want to find it for. What is my cation? Li, and my other one? CO3. Do you see Li or CO3 on the left side? Ignore the exceptions. I see Li and CO3. Doesn't matter which one you use. Which one's easier to read? Right, this one has no exceptions. This one does. Do you agree? It's the same answer no matter which one you choose.
Wait, so you just need to, if at least one of the cations are in that thingy, it counts for both.
Correct.
Like if
They're bonded together.
But if CO3 wasn't in there,
No, it would still work.
You're gonna get
Guys, look. It says soluble ionic compounds. When you have a compound containing any of the following, it's soluble, meaning aqueous.
okay, so
If it's bonded to any of the exceptions, it makes it the opposite.
so soluble is like when it dissolves in water.
Right, and that's aqueous. And if it's exceptions, then it becomes solid. These are solids and they become aqueous. And this is given to you on the quiz, yes. Okay? So Li2CO3. Again, we already established that this one's easier to use, so we will use it. Li is aqueous. Does it have any exceptions? No. So it stays aqueous. Does that make sense? So this compound right here is aqueous. KCl,
I see K and I see C.
I see K, and I see Cl. Again, which one do you think is easier to read? They're both easy to read, but K has no exceptions, what makes our life easier. This has exceptions. So if the chlorine was bonded to Ag, Hg, or Pb, it would be a solid. But it's no exceptions. So it would be also aqueous. Does that make sense? So both of these compounds are aqueous. I go back up to my table. Aqueous, aqueous.
So you put the aqueous after every single
Compound. Or element.
both
Let's balance it.
reactants and,
Say it again.
like both reactants and products.
Correct. Okay, how many K on the left and on the right? How can I fix that? Put a 2 in front of KCl. Does everyone agree? When I do that, who does that also change? So how many CLs on the right? On the right? 2. And how many here? How would I fix that? Yep. Then how many LIs do I have? And how many here? So I'm good? How many CO3s? There's no parentheses here. If there was a parentheses 3, then I would have 3. If there is no parentheses around the polyatomic, it's just one polyatomic.
So it's balanced.
So it's balanced. Okay, so do you see how I have all my, and that's all you're doing for the quiz. Balance it, get the products, type the reaction, give me the states of matter. Okay? Next, number 2, we said it was synthesis/combustion. So if it's synthesis, how do you do synthesis reactions? 2 elements.
Cross the charges and then
Cross the charges. What is the charge of magnesium? Mg. 2 what? And oxygen? What's the compound? Yeah, so what happens with these charges? They do what? They cancel, yes. So what's my formula?
MgO plus O2.
No, just MgO. You just cross it and I'm done. Right? So then you have to go look at your sheet.
what
Do you see Mg or O here? Hold on. Do you see Mg or O here? No. So then look at the bottom of your sheet. Mine, it doesn't say for me. But look at the bottom of your sheet. Important notes number 3. What does it say?
Metal oxides are solids, example MgO.
Right. So MgO is a solid.
We're gonna get this worksheet for the quiz, right?
Just the table, yes.
Wait, not the whole thing.
No.
So not this.
I'm not going to... those are instructions on how to read it. I'm not going to give you instructions on how to read it.
Yeah, but we have to know the MgO for preference.
You have to know that all metal oxides are solids.
What are metal oxides?
Metal with oxygen,
Oh.
except if they're in the table. Okay? Any questions on that?
Yeah, where did the 2 go from the, not the charge, but the 2,
They cancel out.
This
you know,
or this?
yeah, that.
No, don't worry about that. Like, they're not going to be on this. They're not the same. You balance that out to fix it. Good? Okay, number 3. What kind of reaction is that? We said single replacement. What kind of single replacement? How do you know what type of single replacement? Look at the lonely guy. Who is my lonely guy? SR. Do you see that? SR is by himself. What kind of element is he? Metal. Okay? So metal can replace who? A metal. Or a metal can replace hydrogen. There's no hydrogen, so who is it going to be? Okay, who's the other metal in the compound? Beautiful. Okay, now I have to look at my chart to tell me if strontium can replace calcium. Activity series. Activity series. Okay. Can, what was it?
We're gonna get it, right?
Yes. Can strontium
Yeah, okay.
replace calcium?
Yeah.
Yes. So I can switch the places, yes? Perfect. Okay. So who's by himself now?
CA.
So they switch, right? Okay. So CA is by himself, you agree?
Cross the charge,
And I have to cross charges for who?
SR and
Beautiful. SR is what charge? To what? And NO3 is? Polyatomic minus. What's the formula? S.
SR and
SR, parentheses.
NO3
Right, because how many NO3 should I have? 2. How many SRs should I have? 1. Make sense? Okay, now I need the states of matter. Can you tell me the states of matter of calcium? Calcium. What is calcium? Huh?
Not on the.
It's an element, guys. A plain element. What kind of element is calcium? Sorry. Yeah, calcium. What? Yes, metal. And all metals are solids. Most of them, except for mercury. But yes, most metals are solids. Okay? And how about the other compound? What's the state of matter by using my chart? Use my chart to tell me the states of matter. Right. Aqueous. Perfect. Okay? The compound is what? SR, NO3 too?
Yeah.
Okay? Do you see SR on NO3 anywhere here?
Yes.
Where? What is it? NO3 is what? Aqueous, unless bonded to? No exception. So it's always what? Aqueous. Does that make sense? So aqueous here. Perfect. Okay, number 4. Combustion. What? And then what's the like?
It must have oxygen.
Must have oxygen. Exactly. And oxygen as a reactant, not a product, as a reactant. Good. Okay, and then what's that thing in the beginning of the compound? Sorry, at the beginning of the reaction. CH4. What is that? What type of compound is that? Hydrocarbon. So whenever I have hydrocarbons reacting with oxygen, it's the same product every single time. Say it again?
It's the same product. It's
Yeah.
H2O.
Yes. Amazing.
When high school starts in the way.
Oh, no, this is in the study guide. It's written there. So when a hydrocarbon, like this is a hydrocarbon, reacts with oxygen, it forms the same products every single time. CO2 and H2O. You forgot to check. Is this balanced?
Yes.
Right here. How many mg's on the left? How many here? No.
Oh, 1.
How many O's on the left?
2.
How many here? There was a balance. No, how can I fix it?
2 for the
Which mg? So if I put a 2 here, that changes me to have 2 mg, so I have to fix that. And it changes my O's, which I already fixed.
yeah, so it's balanced.
Now it's balanced. Okay, number 3 is balanced?
No.
No, how can I fix it?
Why is
Are you sure? Guys, how many calciums here?
1.
And here?
1.
So that's fine. How many NO3?
2.
And here?
2.
That's fine. How many strontium?
1.
And here?
1.
So it's balanced. Okay? Is number 4 balanced? No. Okay, for this one I like to write it out. I can't pause it. Okay, so split it in half. CHO, CHO. How many C's on the left?
1.
8.
4.
O. C.
1.
H. O. Who can I fix this easy right now? How? No, you're right. No.
It's O.
How? There's a 4 here and a 2 here. 2 in front of H2O. So how many H's now?
4.
How many O's now?
4.
There's 2 here and there's 2 here. Exactly 4. Perfect. Now what?
Put a 2 in front of the O and all the
O2. Now I have how many oxygens?
4.
Everything balanced?
Yeah.
Perfect.
Wait, but.
Hmm.
I never.
You're fine?
Oh, yeah. Oh, yeah.
We're missing states of matter here. State of matter of carbon dioxide. What is this?
Wait, what did you ask?
State of matter. Carbon dioxide. Right here. gas. Carbon dioxide is a gas. And H2O. This is a combustion reaction.
Gas.
Mm-hmm. There's heat being involved, so it's a gas. Does that make sense? Okay. Okay, number 5. We said it's decomposition, right? What kind of decomposition? Hmm?
I don't understand how you have like twice or
Where?
in front of. 'Cause
Here?
you switch. No, not like the bottom. Because you switch O with H.
Switch?
Yeah, you.
No, there's no. That's just. You don't switch anything. That's just what. No, this is not a replacement reaction. This is just the products every single time. I can't look at this and tell you that it's this and this. That's just the rules. The rules tell me if I have a hydrocarbon and oxygen, I will always get this, no matter what. I don't want you to think of, oh, how did you switch that to get that? I have no idea. I have no idea how that works. This is just the rules. You will always get CO2 and H2O when you have a hydrocarbon reacting with oxygen. I get what you're saying, though. Does that make sense? Okay. The rules, there's rules for this one, too. What are the rules for this?
It's binary.
This is a binary compound?
Oh,
There's only 2 elements?
double replacement.
This is a double replacement? There's 2 compounds?
Metal.
Mhm.
Hydroxide.
Decomposition.
Yeah, but.
Okay, where's the hydroxide here? Where's OH?
I thought it was metal carbonate.
It is a metal carbonate.
Metal carbonate.
Mm-hmm. Wait, so how do metal carbonates decompose? Look at your notes.
Metal oxide and carbonate.
Carbon dioxide. Mm-hmm. Metal oxide. And mm-hmm. How do I write the metal oxide? Metal with what's oxide? Just oxygen. What's my metal here?
Na2.
No 2, just Na plus. Oxide. O. Charge. 2 what? Mm-hmm. What's the formula?
Na2.
Mm-hmm. Plus, what's carbon dioxide?
CO2.
Mm-hmm. There you go. What am I missing?
State of water.
Mm-hmm. How do I get that? So, remember, all metal oxides are what? Bottom of your paper. Solids. But only if you can't find it in the chart. Is Na2O here? Na or O? Is it here?
Yes.
Yes. Where?
The second row.
Mm-hmm. Okay, right here. Okay, do you see Na?
Yeah.
So it's in the chart. So what does it say about Na?
None.
Or what's the solubility?
Aqueous.
Aqueous. But if I gave you Al2O3, is this here?
No.
No. So that one would be a solid, according to that bottom of your chart. Does that make sense? This is aqueous, though. Na2O is aqueous. So go back up. Aqueous.
So, oxygen is a gas, right?
Mm-hmm. What about carbon dioxide?
So when I have a situation where there's aluminum and oxygen, you said it's solid, how am I supposed to know if it's, like, how am I supposed to know?
So if I have aluminum and oxygen like this, aluminum is a metal, so it's a solid. Oxygen, you said, is a gas. I crossed the charges, right?
Oh,
And what do I get? That. This, I will then look at my chart. Do I see aluminum or oxygen here? No. So this chart doesn't work for me. I remember, though, that this is a metal oxide. And at the bottom of your chart, what does it say about metal oxides?
but they always say.
That they're all solids.
Okay, I see.
If it's in the chart, go by the chart. If it's not, the metal oxide's a solid. Does that make sense?
Yes.
Good. Any questions on that?
No.
Okay. You want to do some more?
Wait, what's the.
Can you go more into decomposition?
Yeah.
Sure.
So what's
Tell me.
No, I was looking for it.
Oh, yeah. Okay. Decomposition.
Just tomorrow you're gonna do the same.
Tutoring.
No, like during class.
Tomorrow is even.
Yeah, but you're doing the same thing that you did today.
Yes.
I think what I struggle is with like
Yeah.
determining the type.
Mm-hmm.
Sometimes I'm really confused with the type. But like for balancing and like the states of matter and everything else, I
Good.
get it. But the types, it's like
I know that one's tricky.
I don't
So
know.
that's what I'm saying. Like, I posted that document on Schoology that has literally all the reactions summarized.
I don't.
You have to study it. No, it's not in the group chat. It's on Schoology.
Oh, the one you put today?
Mhm.
Okay, then I'm gonna look at that.
Yeah. So you just have to remember. Okay, well, if I have two elements, that's synthesis. Easy. If I have anything reacting with oxygen, that's combustion. And this is a hydrocarbon, so it's CO2 and H2O. If it was just a normal element reacting with oxygen, that's just crossing the charges. Okay? If I have decomposition, I have 4 types. Okay? Let's do that. You guys were asking me about that. So, can you guys tell me what kind of reaction this is?
Chlorine.
General reaction. Say it again? Yes. How do you know that? By looking at it. Just one reactant. There is one reactant. There is one thing on the left side. That's how it's decomposition. Right? There are 4 types of decomposition. They all have their own rules. You now have to tell me what kind of decomposition this is. What is this element? Okay, what kind of element is potassium? Great. CO3 is a polyatomic. If you don't know your polyatomics, you will fail the quiz. If you don't know your polyatomics, you will fail the quiz. If you don't know your polyatomics, you will fail the quiz. Do you understand? Okay. You have to know that ClO3 is chlorate. Bye, thank you. Now I know that I have metal chlorate. I know the rules of a metal chlorate. Metal chlorates decompose into metal chlorides and oxygen. I memorized that. I did my part. I did what I had to do. I studied. I memorized this. That's the only way that I know how to do this, is because I memorized it. You can memorize it too. At one point, I didn't know how to do this when I was your age. I memorized it, now I know what to do. Okay? I know that a metal chloride is a metal with chlorine. Who's my metal? Who's chlorine? One is plus, one is minus according to the periodic table. So what is the formula? KCl. And oxygen is O. 2 because it's diatomic. That's it. Balance it. Balance it. State of matter, yes.
Can you do only the state of matter?
Mm-hmm. Okay. So sorry. So let's do this one. KClO3. Okay, KClO3. Do you see K or ClO3 anywhere here? Which one? K and ClO3. Both of them what? Right, they have no exceptions. They are both aqueous, yes? Perfect. Aqueous. Go back over here. We'll write that down. Okay, KCl. Go back to my table. Do you see K or Cl here? Yes. Which one? K and Cl. Okay, it does not matter which one you look at because it's going to give you the same answer. K has no exceptions.
But if CL doesn't,
Then it won't. Then you won't. It'll make sense. If both of them are there, it's gonna work out. The K can't say something and the CL says something different. It doesn't make any sense. Hello? Hello? Hi, lovely. Yeah, I'm tutoring. I'm gonna leave at like 6. Perfect. Love you. Bye.
Why are you leaving so
Are
late?
they using this?
I have another tutoring thing that I do one-on-one
You
through
do
Zoom.
one-on-one?
No, through Zoom.
Oh.
It's with college kids. It's not.
Do you do
Wait,
it for high school?
No, I can't charge you.
Why?
I'm not allowed to. It's illegal.
Wait, you should your parents.
Oh my gosh, you said that.
I don't. I can tutor one-on-one my people who are not my students. This girl is not my student. She's a college kid at UF. I do it through Zoom. I do it here because it's more comfortable for me. I have everything here. Whatever.
How does she know?
I met her through mutual friends. Okay. So, anyways,
She yours?
You charge them per Zoom or?
Hmm?
You charge them per Zoom?
Per hour.
Like, oh, per hour.
Okay. So, next, I want to know again. Data matter for this is aqueous, according to my table. K does not fall here. It works out. So Cl is soluble. K is soluble. The compound is soluble. So I put AQ for soluble. Oxygen is a gas. Does that make sense what I just did?
Oxygen is always a gas.
Yes. Always gas. Okay. Now I need to put balancing, right? Okay. Is it balanced?
No.
No. It's not balanced. How many K's do I have on the left?
One.
And here?
One.
So I'm good. How many Cl?
One.
How many Cl? I'm good. How many O? How many O? How can I make them the same number? Yes. So where do I put, how do I make this one through 6? That's going to make this become 6, so I can then make this become 6, right? But then this changes this. So I have to put 2 in front of K and Cl to fix that 2.
We're gonna have these, like, something like this in a grid, so that's the
I don't know yet. I haven't decided. I haven't seen it. 5.
5?
Hmm?
That's
I
it?
said this a million times, guys. Mm-hmm.
Oh my god. Wait,
Wait, but that's bad. You can hold it on.
wait, the quiz is only about
Mm-hmm.
on.
No, like random. Can you do bonus questions? We didn't have for the last one.
I'll see how I feel. Okay, ready? So,
Wait.
here is my reaction. I'm done. I'm good. Okay? Can you tell me how I would do this one? What kind of reaction is this? Hmm? Mm-hmm. What kind?
Binary.
Mm-hmm. So what does it break up into?
I don't know.
What are the elements you see in the binary compound? That's it. But what's the O? What does the O have to have?
What?
2, 2.
2. Why?
Which is diatomic.
Diatomic.
Is that 2?
Is it balanced? Yes. Is it balanced?
No.
No. How do I balance it?
Put 2 in front of O and 2 in front of
I gotta make these O's the same by making it 6. 3 here makes it 6. 2 here makes it 6. Then my nickel changes to what?
4. So you put 4 in front of
There you go. And then metal oxide. Is this metal in the table? Is Ni in the table? No. So it stays a solid, correct? Ni, plain Ni, is an element.
Oh, oxygen is God.
It's Ni2O3.
Oh, okay.
Oh, it's 2.
This is what? A solid because nickel's a metal. This is a gas. Okay, what about this?
So whenever O is something else, like it's not gas.
No, it's whatever the table says. Okay? What about this one?
Metal hydroxide.
Mm-hmm. What kind? What kind of reaction?
Decomposition.
Good. And what do metal hydroxides decompose into?
Water.
Water and?
Metal oxide.
Mm-hmm.
So Mg. Oh, water.
Mm-hmm. So metal oxide, what's my metal?
Mg.
2+, and oxide is just
So 1.
Oxygen with 2 minus. So what's the formula?
NGO.
Okay, and what's water?
H2O.
That's it. If you memorize that, no, it does not matter. If you memorize that, you get 100. Water, liquid. This one, solid.
Solid.
It's a solid because of the. Oh.
Because of metal oxide. That's not on the table. Does that make sense? Okay. What about this one? Single replacement. What kind? What do you look at to know? The lonely element.
Non-metal. Replace non-metal.
Which one?
Non-metal replace non-metal.
Beautiful. So bromine is replacing?
Cl.
Beautiful. I need the chart.
Isn't Cl replacing bromine?
No, the lonely guy replaces the not lonely guy. So I need the chart. So let's go back over here. Can you tell me if bromine can replace chlorine?
No.
No.
So no reaction.
So no reaction. Bromine cannot replace chlorine. Why? Bromine is lower than chlorine on the table. Again, bromine cannot replace chlorine because it's too low. Does that make sense?
Yes.
So, no reaction. But, what if I had this?
Yeah. Replace it.
Chlorine can now replace bromine, right? They switch. So, who's by himself? Bromine, and who's with Cl? But I don't bring the 2 over, I have to cross the charges, right? Okay, so then I have NaCl and Br2 because it's diatomic. Does that make sense what I just did? Okay. Do this one for me. We're going to do 5 more.
Yay.
1 of each. And then we'll be done, okay?
Can we do single and double click first and second?
No, I'm not going to tell you which one.
Oh,
It's random. Ready?
yes.
Bye. Have a good weekend. Okay, ready?
Wait, do we all do the 5?
I'm going to do one at a time. I'm trying to think of one. Hold on. Okay, here's the first one. What kind of reaction is this?
Deposition?
Hmm?
Wait.
Decomposition.
Oh my gosh.
Close, but not close enough. Okay. Can you get the products for me?
Wait. Oh, so if it's deposition,
Decomposition.
Decomposition. I tell you which type, right?
No, you just tell me decomposition.
Okay.
I'm asking you now so you can tell me how to do the products.
Okay.
NGO. CO.
Hmm?
CO2.
Nice. Good. Okay. What kind of compound is this? This is a metal carbonate. If you remember from your notes, metal carbonates decompose into metal oxide, and
Carbon dioxide.
that's just something you have to memorize. Cross the charges to get this. CO2 is CO2, right? That's it. And then, of course, you put your rates of matter and balance it, but we'll skip that for now because I feel like you guys are fine with that. Okay? Next. Mm. Which one? Synthesis. How do you know it's synthesis? Right, just two elements, metal, non-metal. How do you write the compound for a metal, non-metal? Cross.
Cross charges.
Okay, chromium has what charge? Two what? All metals, yes please. All metals are, all Roman numerals are positive.
Miss A, do you have lead?
I do not. Sorry.
Do you guys have lead?
No, sorry.
Okay. And then it's bonding with who? Chlorine, which is minus. So what's the formula?
CrCl2.
There you go.
It's done.
It's balanced. And this is, if I went back to my table, I would see it's aqueous. Okay, how about this one?
Single replacement. Metal replace. Metal
Mm-hmm. So who wants to do the replacing? Lonely guy only.
Oh.
Lonely guy, MG, wants to replace who?
Ag.
AG, because he's the other metal. Can MG replace AG? Can MG
Yeah.
replace AG?
Yeah.
So
Yes.
when it's
Synthesis?
no. When a single replacement is when we do that
Mm-hmm.
active, and is it only applied for single
Mm-hmm.
replacement?
Correct. So they can switch. So who's by himself? Bye.
Ag.
MG. And who's with...
No, Ag.
Oh, yeah. Thank you. AG's by himself, so they switched. He's over here now. And MG's with who?
I would say
Bye. Have a good day. Have a good weekend. MG is 2 plus. NO3 is minus. What's the formula?
Mg, NO, parenthesis, NO replacement.
Perfect. Silver is a solid. This is aqueous because of NO3. Good. Okay. 2 more.
CO2, H2O plus H2O.
What kind of reaction is that?
Combustion.
Combustion. How do you know it's combustion?
Because oxygen is a reaction.
Beautiful. And who is it reacting with? What do we call this? Hydrocarbon. When I have a hydrocarbon with O, I always get CO2 and H2O. And I have to do what? Balance it and get my states of matter. Okay? So I'm going to balance it quickly to save time. 3 over here. 3 over here. Maybe 4 over here. 10. 5. No. Whatever. You know the idea. I don't feel like balancing it right now. And then obviously this is all gas because it's combustion and I have heat. And then last but not least, what kind of reaction is this?
Double replacement.
Good. And who's changing places?
NO3 OH2.
Beautiful. Not the 2. Good. So if I were to copy this over, okay, let's I'm gonna duplicate this for a second. Hold on. Okay, I copy this over. Who do you say is changing places?
OH and NO3.
Okay, so NO3, he's going where? Where OH is. And OH is going where? Here. They're changing places. Okay? I'm going to ignore all the numbers in the parentheses for right now. I have to cross charges. Right? AG is plus, OH is minus. What's the formula?
AGOH.
So that's correct, right?
Yeah.
Hey, MG is 2 plus, NO3 is minus. What's the formula?
MG parentheses NO.
Right, so this is wrong. So I have to fix that. And I have to put
Parentheses.
parentheses 2. Right?
Yes.
Okay. Then if I go up here, to my chart. Let's do states of matter. Okay, AgNO3. Can you tell me state of matter of AgNO3? Do you see Ag or NO3 anywhere here?
Oh yeah.
Where?
The first one.
Yes. So what does it say about it?
None.
What does that mean?
It's aqueous.
Aqueous. So there's no exceptions, right? So aqueous. Bye. Thank you. Have a good weekend. Okay. Next, MgOH. Do you see Mg or OH anywhere here?
Yeah.
Where? OH, down there. Okay, so I see OH. What is OH?
It's only
Unless bonded to NH4, first group elements, CaBaSr. Is Mg one of those?
No.
No, so what is it? It's not an exception.
salt.
So it stays solid. Okay? AgOH. Do you see AgOH anywhere?
Yeah. Wait.
So,
Salt.
right? Solid. The exceptions is not Ag. Ag is not here. So this is solid. And then MgNO3. Beautiful. And then, of course, you balance it, and there you go. Good? Whew. I have to tutor another 2 hours. Oh my God.
Alright, obviously.
Bye, Stephanie. Thanks for coming. Have a good day. I want to go to sleep.
Today, I'm gonna take my tea because I have 2
Wait,
minutes.
let me.